By the way, my name is Magesh. I'm here to talk about how we used mobility data, which you might have already come across in certain instances before, to create an audience measurement system for out-of-home media. Perfect? All right, thanks. Okay. So over the last 3-4 decades, there have been significant attempts made to bring in a measurement system to report audience metrics for out-of-home media. However, because providing audience measurement requires continuous monitoring and counting of traffic, with hundreds of towns and thousands of media sites to monitor, many of those attempts could not be sustained for a longer duration because of one single factor, which is cost. Oops. Okay. I'm sorry, I'm still learning this. Yeah. Let's take a moment to understand what is mobility data and what are its components before we go into understanding like how we use this data to measure our audience for out of home actually. Mobility data are essentially the GPS logs generated by mobile apps in your phone. Some of the apps like Swiggy, Zomato, Ola, Uber collects your location information explicitly to provide their services actually. Imagine you are in a street driving or walking. There are many apps in your phone collects your location details constantly. This data is aggregated globally by aggregators who are spread across US and Europe. And we buy this data from one of the data aggregators there. This data provides a lot of details, including the brand of the phone which gave us the data, or the operating system, or the version of the phone, etc. What really matters to us here are 3 data points: the advertising ID, the latitude and longitude coordinates, and the timestamp. Let's pay attention to the advertising ID. It's a unique ID to identify every mobile phone, and this ID is shared by all the apps in your phone. So this means using this advertising ID, I could always bind this data back to you, right? I mean, whichever the app had provided me this data. Though I would not be able to identify whether this data belongs to Magesh or Suresh or Ganesh or whoever it may be actually. To that extent, this data remains completely anonymous actually. Okay. But why using this data for out-of-home audience measurement is significant? Because this data is originally used for digital targeting or retargeting. There are 2 reasons that made me believe in this data. The first one is the truthfulness of this data. Because it is machine generated, the data is true to the location from where it got generated. The second and the most important factor is the one that it allows to map the journey of the consumer from point A to point B in a city. This is exactly what we want, right? I mean, to create a measurement system for out-of-home measurement actually. So with this quick background, let us start exploring further. For the sake of simplicity and clarity, I'll split this presentation into 3 specific units of information. The first one being how we went about creating a panel of anonymous respondents and what are the merits that we see in creating this panel. Then I will provide 2 polarizing case studies that helps in understanding the gaps in the data and how do we fill the gaps using this data. And finally, I will explain how we bind these 2, which is creating a panel and filling the data gaps in providing the audience measurement for out-of-home media. This project had many challenges actually, which I can discuss with you offline. But for this presentation, I will stick to these 3 points. Let's first take a look at the merits in creating the panel of respondents. We have all been using panels, like there was a consumer panel. There are so many panels which we have worked with actually. So panel is not new to us. But if you see, the first thing that you need to understand here is the volume of this data. This data is quite voluminous, right? So every day we used to receive, or rather we receive around 25 to 30 GB of data, right? So handling this kind of a data for a researcher like me is not a small thing to start with actually. Okay? So we get easily drowned in this volume of data. So creating a panel helps us in bringing down the focus to a set of respondents who provide consistent data. This helps us moving away from randomly filtering the data to any particular location based on the latitude and longitude to tracking the performance of specific mobile IDs and understand their contribution to the panel. Having a panel also provides a lot of control. we could clearly monitor the sufficient availability of panel members in each market, the composition of the panel, and the heaviness of mobility of the members in that particular panel. It also provides us opportunity to compare the metrics such as the reach, impressions, frequency, or OTS with other mainstream traditional media metrics such as TV or radio. And lastly and most importantly, having a panel helps us in weighting the data back to the universe. As a next step, I will show you how we curated this panel. We created a database called PollStat. Again, I wanted to remind you that this data is voluminous, and the size of the data is around, or every day we get somewhere around 5.5 to 5.6 crores of unique machine IDs actually. So this PollStat gathers two specific information points. One is whether a mobile phone had polled the data or not for a specific date. And on that date, how many sites they have got exposed to actually. When you aggregate this data over a period of time, this not only provides us with insights on the consistency of polling, but also the heaviness of mobility of the individual actually. Another important aspect here is that it also helps us understand when a mobile phone stops providing us the data. So the process of panel curation or panel creation relies heavily on the consistency of polling. So we want the members, right, who are there as a part of the panel to give us the data consistently on a daily basis. For example, if we take a small window of just 1 week, we expect a mobile phone to poll the data at least 4 out of 7 days. That is, more than 50% of the days a mobile phone should have polled the data. While curating the panel, we look for consistency of polling over a window of 120 days. If we are curating a panel for the month of October, let's say for example, we will look into October, starting from October 30th, we look back 120 days into the panel and see what are the patterns that are emerging in this particular panel actually. So the minimum data hold for a period is 30 days for any mobile ID before they become part of a panel. What we have observed over a period of time is that we also lose close to 15 to 18 lakh mobile phones, right? Or mobile phone IDs. They don't give us the data on a monthly basis, actually. But at the same time, we are also getting like 15 to 18 lakh mobile phone data coming to us on a every month. The new mobile phones are coming and giving us the data, actually. This also impacts the weighting and the reporting. So what we are doing is we are curating this panel on a monthly basis. So every month, the panel gets refurbished or renewed, right? With the newer members, and the older members are getting, moved out, and it also impacts the weighting process and the reporting process, actually. We receive this data from all over the country. We have seen the data from the smallest of the towns in remote locations of Northeast to the heaviest data churn happening in markets such as Mumbai and Delhi. Currently, we have curated panel members in 512 markets across the country, providing us data every day. We do have provisions to report at least 2,000 markets in the country. One of the key takeaways here is that the application of market research practices, such as building a panel, setting up standards on what makes a panel, weighting and creating a dynamic reporting process, provides a lot of control and clarity in otherwise a very chaotic data set actually here. I'll move on to the next section of this presentation, which is bridging the gaps in the data. I'm going to show you two specific case studies. The problems that we address here are polarizing in nature, but stems from one single issue, which is traffic. Imagine you are stuck in a traffic jam for 15 minutes, and your mobile phone is churning data at a frequency of 1 log per minute. This means we would have received 15 logs in 15 minutes. If there is a media site in the same vicinity, and if we don't clean up this data, it would mean you would have seen the site 15 times. In other words, the impression for this particular site would be 15. Besides, it also spikes the frequency of the exposure as well. There is another scenario where this could happen. It is not uncommon to see the media sites on top of the residential buildings or facing residential buildings. If the members of the household continuously provide us data right through the day, this will also spike the impressions for the site actually. To balance this, we remove the duplication of logs within the hour for each media site. So this removal of duplication of logs is not based on the MAID or the machine ID or the member that is providing the data, but the removal of logs happens at a media site level actually. For example, if a mobile phone provided us 6 data logs within an hour for the same media site, we delete 5 of them and count the impression as 1. The key takeaway here is that by removing excessive and frequently recurring data logs from the same mobile ID, we can bring in a stability to the overall impressions number as well as normalize the frequency of exposure. Our next case study has got a background story to it. In Mumbai, there is a street called Cadle Road. This road is approximately 3 kilometers in length and is dotted with multiple traffic lights and many media sites. The problem here is that we were getting higher number of footfalls for certain media sites and not for others. With all these sites in the same stretch, we could not assess what exactly could be the issue. So we decided to visit this location and as an example starting point and see the dynamics of that location ourselves actually. I personally went to this location and parked myself near the Siddhivinayak temple actually. This panel is not curated by us. We don't really own this panel, right? I mean, no, we don't know any of the members of this panel actually. But I was just simply staring at the traffic and the traffic is continuously moving actually. So I was not really sure what I have to assess there actually. So I was just waiting there for 30 minutes and saw all the vehicles and cars and bikes are moving around and I could not really guess anything. So I just went back and started walking towards Mahim actually. Right? I spent around 3 hours in that particular stretch, and there were so many signals and crossings in that particular stretch. And at some point in time, I just lost my cool and then took a cab and went home actually. We started digging in deeper into the data again and looking for answers actually. One day I realized that all this while, right? I mean, we have been looking at the data only from a media site point of view. We are not really looking at the data from a mobile ID point of view or the respondent's point of view. Right? So when we reinvented this entire wheel, we started looking at the people who are giving us the data actually. So this is a big change in approach for us, considering the huge volume of data that we were getting or we have to manage actually. So it took us almost around 15 to 20 days for us to pick up a few mobile IDs that were giving consistent data that we could clearly filter down to this particular street, which is Cadle Road. What happened is, some of the mobile IDs that were presenting the data for one media site is not providing the data for the other media site, which is there in the same stretch for a certain distance actually. However, the same mobile ID is again providing the data for some other site in the same stretch actually. So the problem here is there is no pattern to it, right? We don't even know when the person is giving the data or when he is not giving the data, or to which site he is giving the data and to which site he is not giving the data. When I overlaid my understanding of Cadle Road, especially the signals and crossings, we could see most of the traffic get aggregated in the signal junctions basically. And the sites between the signals, right, I mean, they were getting lower numbers actually. So we know that we are missing the data, right, I mean, especially when the traffic is faster. Okay? So, we need to figure out, two things here. The first thing is, how can I identify the linear alignment of sites? Right? And the second thing is, how do I get a sequential order of sites? The first thing is, when I'm saying linear alignment of sites, I need to understand whether the sites are there in one single straight road actually, right? I mean, are they there in the same road actually, right? And the second one, the sequencing of sites is which site comes first and which site comes second and which site comes third actually. So the sequencing is really important. So that is where we applied the distance and bearing, process actually. So it's a discovery for us, right? So, what this distance and bearing does, right? When you sort the geospatial objects ascendingly only on latitude, you will get them aligned from south to north, okay? Especially if you are in the northern hemisphere, okay? Bearing is the angle of deviation from a point. With latitude and longitude as spatial points, we can identify the angle of deviation of one site to the other. We have to define a threshold for this bearing and the distance to start with. We know the visual span of human eye is approximately 120 degrees arc. However, most of this arc is peripheral vision actually. So we decided to take half of it and set 60 degrees arc as the threshold for bearing. If you take a straight line at 0 degrees, the visual span of 60 degrees would cover 30 degrees left and 30 degrees right from the site. As a next step, we took two directions of road stretches. One going from south to north, which is a vertical alignment, another one which is going from west to east, which is the horizontal alignment actually. When we applied this approach on top of the media sites that we had, we could map all the sites linearly and find out the bearing and distance between each site. We took a cutoff of 1 kilometer stretch of road for the distance and bearing based on aggregation of sites. This threshold is derived from assessing the distance gaps between the logs for various sites such as Cattle Road. To remove the anomalies of clustering of sites, we used an algorithm called dbScan, which is density-based clustering algorithm specifically used for entities that have geospatial relevance. Using this method, we are not only able to find out the sites that are linearly aligned in the same road, but also the sequence of sites. With this additional understanding, we created our own algorithm that attributes the data from one site to the other site, actually. Though this method must satisfy certain conditions, such as the transit of MAIDs or the mobile phone must be sequential. That is the first important parameter. And it must be within one single hour. And we must have at least 3 sites in that same stretch so that we can use that to attribute the data from one site to the other. So here you have to understand that we are not just copying the data from one site and we are dumping it onto the other site, right? If only we see the person or if we see a person in site A, and if we don't see him in site B, but we have seen him in site C, then we attribute the data of site A for that particular MAID to site B, actually. Okay? So the key takeaway here in this is, we are able to scientifically attribute the data to a site that is deep-rooted in logic, actually. As an outcome, this provides comparable data between the sites in the same stretch without losing the sanctity of the data. Now we have covered how we curate the panel of anonymous respondents and how we fill the gaps in the data. Let us take a look at how do we go about measuring the footfalls for each of the media sites here. We deploy 3 different methods for calculating the reach and frequency. These 3 methods differ based on the information that we have about the media site. The first one being the most basic approach. It's a radius-based approach. This is adopted when we don't have any information about a media site other than just the latitude and longitude of the media site, actually. So in this case, we create a 50-meter radius bubble around the media site and monitor all the footfalls within the bubble. This will include the traffic on both sides of the roads, and if there are residential complexes or commercial properties near the sites, it will include the mobile logs from those properties as well. The next method is a bit more interesting, actually, and it is sounder in logic as well. So here, we take 2 points on a map. One is the close visibility point of the media site, and another one is the longer visibility point on the media site, actually. So by using these 2 data points, we are able to map we are able to get 2 different insights here. One is we are able to get the direction of the traffic that flows through that particular site, and also we are able to see the visibility span of that particular site. So how this helps, if you have 2 sites in the same location, a site which is really large and owned by a media owner, and a site which is really small owned by a media owner, the site which is really large will have a longer span of visibility as compared to the smaller site, actually. So the site which has got a longer span of visibility will have a lot of data coming to it, or more people will have an opportunity to see it as compared to a smaller site, actually. The third method is, right, we apply this method when the visibility of a media site is multi-angled, actually, meaning the site could be seen from multiple directions, actually. Here, we see a site in Haji Ali Junction that has a viewability from different roads, actually. When we clearly define the catchment for this site, we are able to track the footfalls within this complex polygon, actually. We see a lot of interest among media owners to use this particular method because this increases their catchment of audience. This also comes in handy when we want to isolate retail catchments, the retail establishments or the malls or the supermarkets, to measure the footfalls. The key takeaway here is that with all these methods, we are able to provide the reach, frequency, impressions, OTS, and all the other metrics that one would get for a media such as TV or radio or print, for outdoor as well. Okay, over the last 10 minutes or maybe 15 minutes, we saw how we curate mobility data and bring in controlled approach to use the same for audience measurement for out-of-home media. If I have to summarize the advantages and disadvantages of using this mobility data, the biggest advantage that I see lies in the cost efficiencies that this brings in, actually. With lower cost, this model provides an opportunity for higher sustenance over a longer period of time and makes the metrics viable even by the smallest of the media owners, actually. However, the other benefits also includes the ability of the data to provide comparable metrics such as reach and frequency, OTS, etc. for the out-of-home media. This method allows for daily polling and daily reporting of our data for thousands of sites across the country, actually. Besides, we can also track the consumer journey through the city and understand where they are going and use it for consumer profiling as well. Like every other measurement exercise, this method too has its own rather drawbacks. Since the data is completely anonymized, we cannot derive classifiers such as SEC or or similar other demographic parameters which we normally use in our regular day-to-day market research actually. So one must be prepared to move away from using these demog parameters when you're using this kind of a data set. While we brought in a lot of control in otherwise controllable data, still this data remains uncontrollable as it is not specifically designed for out-of-home measurement, or it is not a panel, or data is not coming from a panel which is curated by us actually. I will end this with one last thought. What I believe makes this model stand out is that there is absolutely no difference or reference or benchmarks that we could refer to actually. Every step that we took is a trial and error, but the outcomes we see are fabulous because we never lost sight of logic or compromised on the basic market research dharma. That's it from me. If you have any questions, you can ask now. Are we cool? Yeah? Sure. Thanks.